Okay, so this lesson is on probability. This is 12-4. And we're going to be looking at what is probability, probability of a single event, probability of multiple events, using table diagrams or tree diagrams. We're going to use an outcome grid and counting principles, multiplication counting principles. All right, so when we first look at probability, stop it, it's not moving. When we first look at probability, what is probability? Anybody? Yeah.
The chances of picking something out.
The chances of something happening in the future. So we can take probability and we can actually draw a picture of it. Create a probability line. Where on one end of the spectrum, it's impossible. And on the other end of the spectrum, it's certain that it's going to happen. So let's look at different kinds of events. An impossible event would be something like today at 4 o'clock on the freeway, you're going to see a chicken driving the car next to you. Okay, so a chicken. So a chicken driving next to you. Not driving in the car, but actually driving the car. It's never going to happen. So what chance would that be? Impossible. What percent? 0%. Shh. If I convert it from a percent to a decimal, what decimal would that be? 0. Now, the possibility that I will go to sleep tonight. Okay, let me do this. No, let's not go to that one because I have insomnia. Shh. So let's look at the possibility that the sun will set today. So, shh. You guys, I'm recording. So, the possibility of the sun setting. We may not see it, but it will set. Because of the way that the planets work and we're rotating, the sun will set. What is the chance, percent-wise, Melody? 100%. And what decimal would that be, Melody?
That would be 1.0.
1. Just 1. So, probability, so certain, we're looking at sunset. So we said that impossible, on one end of the spectrum, it's 0, and on the other end, it's 1. So probability is a number between 1 and 0. It's a decimal amount. The likelihood that I'll give homework. What would you... Let's go 90%, about 90. We'd be about here. Let's say 0.9 or 90%. When you have a baby, the chance of it being a boy. Right in the middle. 0.5 or 50%. So we could express probability as a percent, as a decimal, or as a fraction. Okay? That's 0.5. 0.5. 0.9. Okay. So now, probability is a number, it's our number of favorable outcomes over our number of possible outcomes. So if I were looking at this situation, a woman's having a baby, what is the probability that it'll be a boy? Favorable outcomes would be boy. Out of total outcomes, the probability of a boy, that's how I read that, over boy over possible outcomes could be boy or girl. Now on the top we have how many? 1. And on the bottom we have how many? So that's 1 out of 2, which is 50%, or 0 and 5/10. Now, do you notice how I'm writing my probability? The P, and I put the parentheses of what I'm talking about, the probability of a boy. So probability is really about predicting the future. Okay? So probability is always expressed as fractions or decimals or percents between 0 and 1. And so here's how we write it. You might see this. Probability is greater than 0 and is greater than or equal to 0, but is less than or equal to 1. Impossible is 0 and certain is 1. You're going to have to write quick. All right. Complementary events are two events if two events that kind of go together. Like it's the sum of events. So let's talk about storms. The possibility of a storm on a weekend versus a storm during the weekdays. If I take the storm on a weekend, how many possible days are there in a week? In a week? 7. So this would be 2 out of 7. Okay? But the possibility of a storm on a weekday would be 5 out of 7. Right. And when I add them together, look what I get. The possibility of a storm any day of the week, it equals 1. Complementary events always add up to 1. So basically when we have these, we add the probability. And their probabilities should always equal 1. Okay, the probability of it raining versus the probability of it not. If the newscaster gives you a 30% chance of rain, what would the probability of it not raining equal? 70, and altogether that equals what percent? 100% or 1. Do you understand how complementary events equal 1? Let me see a thumbs up if you're understanding this, a thumbs down if you don't. Okay. Who said I? So, if the newscaster gives you a chance of rain, and they said 30% chance, what chance is it of not raining, Abdul? So, oh, what did I call him? Abdul. Because it's I'm not going to try and say it. Okay. So, when I add those probabilities together, Manny, what does that equal? And if I convert the percent to a decimal, remember to convert percents to decimals, we have to move our decimal once, twice to the left. So it equals 1. That's why complementary events, the probability of something happening versus not something happening, something not happening would always equal 1. George?
I get that, but I don't get why. How did you get the 30% and the 70%?
I'm just saying, if a newscaster says it's 30%, well, if the newscaster says it's 40% chance of rain, what's the percent of not rain?
60%.
And when you add those together, it equals 100% or 1. Complementary events will always add up to 1. All right, a bunch of different vocabulary words. An event. An event is when we do something to create, like spinning the spinner, rolling the dice, flipping a coin. That is a event. Okay? Our outcome are your possible results. our sample space is like the list of all possible outcomes. So our probability, whenever we're figuring out probability, we take the probability of favorable outcomes out of the total possibility, or the sample space. Number of possible outcomes, all possible outcomes. So if we look at the probability of spinning a 3, the probability of spinning a 3, okay? When I spin the 3, how many possible chances will I have of spinning a 3? Alexander?
3 out of 6.
To spin a 3? Oops. Flicking that spinner is going to be, how many 3s are on that spinner? Alexander? 1 out of how many numbers are on there? 8. So what is the probability of spinning a 3? 1 out of 8. Okay, what is the probability of spinning an even number? Gio? How many possible even numbers? If you can't give me the breakdown, then I'm not going to call on you.
You can spin 4.
4 out of how many? And that reduces to 1/2. So always give it reduced, but when I'm calling on you, I need you to break it down. Okay? Pause the recording and you try the next 2. All right, what is the probability of a number less than 6? Yes. 5 out of 8. Good. And what is the probability of a composite number? What's a composite number? Gio?
A number that's not prime.
A number that's not prime, a number that has more factors than one in itself. Okay. So, composite numbers. What is the probability of spinning a composite number? Aiden?
3 out of 8. Oh. No.
1, 2. Yeah, you're right. 3 out of 8.
Yeah.
I'm wrong. I was sitting there thinking about it. Okay, 3 out of 8. Can that be reduced? No, we could turn it into a decimal if we wanted. All right, so probabilities of single events. We've talked about the probability of a complementary. 2 events when you add them together. We've talked about now the probability of a single event like spinning a spinner. Here's one, the letter chosen at random. If I have all these letters, like Scrabble letters, in a bag, what is the probability that I'll pull a G? Yes.
You have 1/7 of a chance to pull out the G.
Perfect. What about an A? Bella?
2/7.
Good. And what about an A or a B? Dylan?
3 out of 7.
3 out of 7. You get it? You understand? And what about the probability of not pulling an E? Okay, not pulling an E. Okay, what is the probability of not pulling an E? Yes.
6/7.
Okay, so we have, 6/7. Exactly. All right, so here's another way they could ask it is with cards. The one thing I want you to know is the deck. I really don't want to go through this because we don't have a lot of time, but like the probability of pulling an ace. There's 4 aces in a deck. You have to know this kind of stuff because this could come up on a math question. Think about the one thing, I think, clubs. How many clubs would there, how many, we said there's 4 out of 52 aces in a deck. What about clubs? Yes.
4 out of 52.
No, because clubs starts at ace, 2, 3, 4, 5, 6, 7. I mean, clubs is ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. How many?
I think it's like 11.
Nope. Yes.
13.
13. So it's 13 out of 52. Shh. Okay? 13 out of 52. Now think of your face cards. you've got clubs, hearts, diamonds, spades. And you have 3 of each. How many would that be?
12.
12 out of 52. And then you have to reduce it. Okay? And not a heart.
Wait, aren't face cards 1, 2, 3, 4, 5, 6, 7?
What face cards are your Jack, Queen, and King? That's a face card because it's got a face of a figure. Aiden.
39 out of 50.
Right, 39 out of 52. So you get the idea? Because we subtract that 13 out, and that gives us 3/4. Okay. Now, multiple events. Rolling a dice. Okay, the first event is rolling 1 dice. The second event is rolling another dice. So let's say I have, this is 1 dice and this is the other, and I roll them. What is the event that I'll get a sum of 7? So let's look at, if I roll a 1 and a 1, what will the sum be? 2. And if I roll a 2 and a 1, what will the sum be?
3.
Okay, so you get it? And I just keep doing this. And then I look at all my possible sums. And so what is the sum of me rolling a 7 now? 6 out of?
6, which equals 1. Oh, no.
It's not 6 possibilities here.
36.
I have 36 possibilities. So it's 6 out of 36, which is 1/6. This is what we call an outcome grid. So every time I'm adding 1 and 1 and I get that 2. You know, I get all these different, and then I look at all the possible outcomes, and I have 6 favorable outcomes. All right, another way we can show the math of multiple events is with a tree diagram. So let's say I have a nickel, a dime, and a quarter that I'm tossing. The nickel, I have the possibility of getting a heads and a tails. If I roll the heads, when I roll the dime, what are my possibilities of rolling on a dime? A heads or a tail. What happens if my nickel, I rolled a tail, right? Then when I roll the dime, again, I have the possibility of rolling a heads and a tail. And I do this for each coin. With the quarter and the heads, I could roll a heads or a tail. Or with the original tails, I can roll a heads or a tail. Does this make sense? So as I eventually get all the way through, then what I can do is now look at all my possibilities. Stop and watch. Stop. Here's one. Heads, heads, heads. Heads, heads, tails. Heads, heads, heads. Heads, heads, tails. Heads, tails, heads. And then look at, stop. Look at the question they're asking. So once I've figured out what all the possibilities are, I look at them and which one only has 1 heads. Isaac.
Tails, heads, tails.
Perfect. Tails, heads, tails. Okay, and so we have 3 possibilities, and that would be 3/8. Okay, so as I continue, now once I've done all this, I'm going back a little bit because everybody was leaving. Once I've got all my different outcomes, remember I can look at them. Here's a heads, heads, heads. Then I have a heads, heads, tails, and I'm listing it. Does that make sense? And then I've got a heads, tail, heads here. And then I have a heads, tail, tails. And so we list all of our possibilities. Once I do that, I can answer my question. The probability of only 1 heads, I've got this one right here. I've got this one. And I have 1 more. So that is 3 out of 8 possible outcomes. So 3 favorable outcomes out of 3 total outcomes, or the list of all possibilities. And which one, for number 2, I'm looking at least 2 heads. So I've got the second one. Oh, the first one, because there's 3, so that's at least 2. The second one, the third one, and then the 5th one has at least 2 heads. So that would be 4 out of 8, which reduces to 1/2. Multiplication counting principle. How many ways are there for Terry to leave home to go to the store or to go to the bank and then go home? So from home, if there's 4 routes to go to from home to the store, and 3 ways to go from the store to the bank, and 1 way to go, or 2 ways to go from home to the bank. Now the black lines are all the different paths. One way that we can do this is use the multiplication counting principle and just multiply all of our different paths. 4 ways times 3 ways times 2 ways is 24. I can also create a tree diagram if I wanted to, where I do from home. I could create the home to store and then make my 4 lines. Let's start with home. And 1, 2, 3, 4. That's store, 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 store. Then I could do my store. There's 3 ways. 1, 2, 3. To the bank. Bank, bank, bank. Bank, bank, bank. Bank, bank, bank. Bank, bank, bank. Then from the bank, there's 2 ways. To home. Back to home. But this becomes very cumbersome. So if we just multiply it all out, do you see? I don't want to sit here and do this 24 times. All right? A lot of times this kind of question comes with sandwiches. You'll see like a sandwich question. The sandwich type of question would be, I'm going to give us a blank sheet here. Okay, if I have, this is like a typical Subway question. Let's say we have 3 different kinds of breads. We have, white, wheat, and jalapeno. Okay, so we've got our white, wheat, and jalapeno. I've got 2 different kinds of spreads. Mayo and mustard. Mayo and mustard. And then I've got 2 different kinds of cheese. Swiss and cheddar. Swiss and cheddar. And Swiss and cheddar. Swiss and cheddar. Swiss and cheddar. Swiss and cheddar. And then we've got 3 different kinds of meat. Let's go turkey, bologna, salami. Turkey, bologna, salami. TBS, 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 TBS. Okay, this becomes very cumbersome. So what I've got is, for my breads, I have 3 possibilities. For my spread, I have 2 possibilities. For my cheese, I have 2 possibilities. And last but not least, for my meats, we have 3 possibilities. So if I multiply them all together, what I get is equal to the total 9 times 4, it's 36 possible sandwiches that I could have. And remember, here's one. It could be a white sandwich with mayonnaise, Swiss cheese, and bologna. Here could be another one. White bread, mayo, cheddar cheese, turkey. Here could be another one. So this is 36 different. How about green or purple? Let's go, wheat. Let's do mayo. Sorry, wheat, mustard. And then we just keep going down to the type of meat, bologna. Okay, Swiss cheese with bologna. So when we end up down here, I'm going to end up with 36 different possibilities. So this is a typical type of question. Different types of how many different 3-digit area codes are possible. So how many different digits are there possible? We've got our digits range anywhere from 0 to 9. So we've got 0 plus 9 more, so that makes 10. And the second time I've got another 10. And then the third one I've got another 10. So when I multiply those all together, I have 1,000 possibilities. Don't want to write all those down. Okay? So I'm going to stop the recording there because that pretty much covers it. I'm going to pause it and look ahead. Then I will, I'm going to just pause it now, and that's the end of the lesson.